Hi, this is Cole Meir, the programmer for Ellipse, and I wanted to quickly give a bite-sized feature demo that's shorter than the one on my YouTube channel on how this um, elliptical orbit actually works within the game. And you can see on connections like that, we have this very eccentric, which means elliptical orbit, but we can also have these more circular orbits, if I can show, when the ship connects on the outside, as so. And there is math behind that I'd like to show off on how we were actually able to discover this for our programming sake. So if you know the equation for a circle, we have r times sine theta and r times cosine theta parametrically in the x and y direction. So over time, you're going to have negative 1, 0, 0, 1, 1, 0, and 0, negative 1. And that's going to keep going around and around over time as we go up, and that's what the z direction is showing. Now, the equation for an ellipse is actually exactly the same as a circle. The difference is we have to break it down further into a r, that's the y direction r, so this is ry, and then we have an x direction r, which is rx. And because these are backwards and I'm used to having y in the sine direction up here, we see semi-minor axis is green, semi-major axis is red, and this r in the ry, which could be rx, is 2, and this one could be 1. And these are just estimates. This is only a conceptual explanation. But the point being that if you break down this r, y, and rx into separate components, and it's not a constant radius like that of a circle, you only add one more variable, but you can completely change the way that the ellipse orbits over time, or oscillates over time. So over time, instead of having this perfect circle going up, you can have this long, stretched out oval that keeps going back and forth. And that's how we get the equation for ellipse as we increase theta. The same is true in the code. If I show you this bit right here, it should look kind of familiar. We're multiplying a major axis and a minor axis, which are our respective radius values, radii values, and multiplying that by a sine of theta and a cosine of theta. And this top bit and this bottom bit are the exact same piece of code, other than we are either increasing or decreasing theta based on whether or not we're traveling clockwise or counterclockwise. So yeah, that's exactly the quick conceptual overview of how the ellipse is being programmed. One last thing I wanted to show quickly is that you might notice that we're not exactly setting the location of the ship based on these values, we're setting the location of an orbiter. And if you saw when I was playing, there's that little ball connected to the back of the ship. This is the actor that's actually having its position changed by that bit of code. And the reason for that is, well, there's a couple of reasons, but specifically we can assign a lot of values, get grabbed out of that orbiter that allow us to do certain things like set the eccentricity. So if we can check what the semi-minor axis of the ship is, so if let's say the planet is right here and the ship is connecting right there, right at this moment we get our semi-minor axis, and then our semi-major axis is going to come over here. And the nice thing about that is if we change the eccentricity on like those outer orbits, we can get something that's more circular, which would mean that this axis and this axis would have closer to the same value. And that is happening right here. We tell how close the ship is to the planet, and it looks very smooth in the game, but you can see there's actually only 5 different sections of how eccentric we're actually going to set that orbit to be. And we're multiplying it by eccentricity. I won't show you the equation, but this eccentricity is actually a really nice value that allows us to figure out eventually how large this major axis is going to be relative to the minor axis upon connecting the ship. And that is how we finally get, when we connect the ship here, a more eccentric orbit, and if I can do it, a less eccentric orbit, more circular on the outside of the planet. So yes, that was a quick demonstration on how the elliptical orbits work in Ellipse, and I thank you for listening.